Hello, my fellow YouTubers. This is Roy back again. Right now, we're working off of two beautiful marine batteries, brand spanking new. I got two of them together. So we're coming out 24 volts. Actually, 26 volts, 26.6 volts. There is the start of the wheel. Now I get a better, turn the camera around. See if I can get a little better angle. And we will get into this live broadcast. What do we have? We're working to build a Leedskalnin replica. Right now, this is the original 1916 flywheel. It's really thick. So far, I have it set up. I used this plastic tubing inside diameter 1/4 inch and put the tubing around the 1/4 inch bolts so we don't touch any of the inside of the magnets. We want to make the inside of the magnets, we don't want any continuity between the magnet and the frame itself. Now we're going to have a lot of steel here, but we don't want continuity. Continuity is the enemy. So, with that being said, with no further ado, let's go ahead and charge up a couple. Well, I got these right there. I got half done. And I got to do the other half. So while nobody's on right now, happy holidays. Got my shirt on. Got the PMH sitting here. Compass. Get you a little bit more angle coming down. Maybe I can get you closer. And we're going to charge some magnets real quick. So I'm looking for this side to be north because this side is south and that side's north. So you want opposing fields, and that's how you'll charge this. Pretty amazing, right? So we'll go ahead and we know that's north, going to the south. And we'll go ahead and, I don't know, I like to get in there at least 12 times. 6 to 12. Check it, and it's screaming. Real good sensitivity. Let's check it. That's some good magnet strength to be holding that up. Holy cannoli. Huge. All right. So I'm going to show you something quick with this. Get these out of the way. Let's go ahead and, now this is real heavy. I can't tell you how heavy it is. It's real heavy. Well, that ain't gonna do it. Huh. Maybe it's only the 1.5" square stock that does that. So let's check it one more time. Let's give it another run. That'll take your hand off. It's strong. I can plow through these pretty quick. Alrighty, there's a quick 10 right there we just did. Might as well do them all, huh? I need room for those. I guess we can start by putting, I got this rubber, and we're gonna put some rubber down. I guess we're gonna have to lift off the lid. And let's start putting some rubber down. And the reason we're putting the rubber down is because we want to isolate the V-shaped magnets from the chassis itself. You can't have the magnets and the electricity connected in continuity. It just, I'm seeing it destroy the magnets. So since we charge these right here, we might as well stick them on, and we'll check to see what they are. That's north, that's south. And we'll grab a little that'll balance it out there. You got the rubber on there. So that's what we're looking to do there. And then the top iron that you see is going to have to be isolated as well. And we don't want that iron to touch, because you'll have that upper gear ring that's going to be sitting there. And we'll get a perspective by putting the ring in place right now. Maybe I could just cut the rubber so I don't have to poke it in. So that's how it'll sit. We'll have no connection, no continuity, no metal connection from the top of the chassis to the bottom. Tons of iron though. We'll have, you know, between this bottom flywheel plate, which is the original Model T 1916 Model T plate, off their flywheel. So this plate here is where the original Model T Ford had 16 of these V-shaped magnets on this wheel here. When I ordered them from a place called Lang's Old Car Parts, Model T. That's their address, their phone number. If they no longer sell them without having cores, then just look online. There's a couple other Model T places that has bunches of these stashed up, and they're whole with the flywheel and the 16 magnets. So you can get them like that dirt cheap, but they're heavy. So if you're gonna spend a good amount of bucks, you could might as well get them with the flywheel, because the flywheel cost me an extra, I don't know, $85 or maybe $95, I guess. Then shipping was expensive. None was cheap when I first ordered it. But these are real strong magnets right now. I wouldn't be surprised. Look at that. Look how strong they are charged up. That's crazy. Let's try the big guy. I probably doubt this. This is huge. Oh, Mary Louise there. That's some strength going on there, guys. Thanks for being on there. Give a shout out to you. Say hi. If you did say hi when you popped in, I didn't see it. I was knee deep in looking at the wheel. But leave a comment right now and I'll give you guys a shout out. So the next thing we want to do is, I guess we'll move on to and keep going around. So right here we have north. I got these other 5 magnets I just charged. Let's see what the polarity is on these guys. These are so strong. They're fighting me coming over. They're you should see these things. I'll put them over here. They're crazy strong. All right, so we got south there. We got north. So we got to flip these suckers because we want it to be north and north. Yeah, they're all sticking to each other real strong right now. There we go. It's going to take some time. This ain't going to be one live broadcast. We'll have to do this in a lot of segments. I spent already today probably, heck, let me see, it's 7 o'clock. Probably about 10 hours out here today, stripping it down. So you can see right there, you got your magnets lined up. What we'll do is I'm gonna take a aluminum flashing and make a circle. And the circle that I make will represent the back. And the back of the V-shaped magnet will have a stopper. And that stopper will show me how far out these come out. We're looking to be about 1.5 inches to 1 3/4 from this edge here to this outside. So if I went and checked it right now, which I don't see my tape measure, here it is. It really don't matter right now because I have to get them all in a circle. But right now it's about 2. So we'll see how that comes, but they'll probably come out even further. No, 2, so it'll go in. Yeah, like that. But I gotta make sure the rubber's going everywhere because the continuity thing really matters between the magnets and the wheel, the chassis. All right. These magnets are so strong, they're sticking to each other, sticking to everything. They keep moving on their own. So we got south, north, south. Let's grab a charge set over here. Okay, south, south. Bada bing. All right. always got to check, double check. Imagine putting one in backwards. Forget about it. So we got south, north, south, north. That is some strong. As you add more, they get stronger and stronger. So they're real strong right now. I like that rubber, Home Depot, dirt cheap. And don't forget you got the not PVC, but just water, plastic pipe, polypropylene pipe. All right, so we left off on the north. Fighting the magnets now. Can't demagnetize these suckers right now. Oh yeah. So we got good placement over here. An edge wheel on the inside. In this picture, he's got 4 bolts coming up, and they're not in the magnets. And the other 8 that go around the outside perimeter, they are in the magnets. So everything is getting placed right back. I built this wheel on and off so many times. It's pretty easy for me to have to rebuild it. But this time, the difference this time, I'll say to everybody, is that I know it's more about what I know, what I'm trying to get out of it. It's not about just using electromagnetic to make electric through a coil, because we're doing that, been doing that. It's different. It's using the earth. So let's move on to the next section here. We have to work our way around. I do got the clover ring that's got rubber on the bottom of it too, and it'll be isolated and as well. And what this will cause, and think about this, if the magnets, the V-shaped magnets are isolated from the chassis, and we have this metal ring on the top, and the metal ring that's underneath the flywheel is connected through these bolts. So the flywheel and the two metal rings become part of ground, okay? Be the grounding, a bonding. This metal ring isolated and this metal ring isolated will be choosing what magnetic poles that they will represent, because one will be positive and one will be negative, but what they'll be doing is they'll be swapping poles. Now hear me out. The reason they'll be swapping is because we already showed on the couple videos ago that when you move the magnets past the iron swapped. The iron kept, and the energy moved through the iron. Here, here you can see that the energy runs through the iron, and the iron itself becomes polarized. So that means this upper ring and this lower ring in motion, theologically, should have a difference in potential, because one is chasing the other. And by doing that is this upper clover ring has a clover. The other one's a round ring. So the round ring will have a full racetrack to run. The one on the top is going to start curving the magnetic field, so it starts shaping the magnetic field. As the wheel turns, though, I'm talking. I'm not talking about when it's sitting still. I'm talking about when it turns. So your magnetic field starts to warp a little bit and turn. And by doing that, let me grab something else here. By doing that, so by doing that, with the handle, moving, can you guys even see the handle? No, you can't. What the hell? So with the handle now, it has a little key sticking out of the side of this. And the key, this sits down further. The key looks like a spark gap because it has like a finger point coming out. And he has these upside down bolts, 4 of them, inside the concrete. I believe the magnetic bolts are magnetized. And I believe he has the bolt coming in on an angle through the circle part of the back here, but leaning on the one side of the leg of the magnet. And the leaning on a bolt on one side of the magnet, we already know that when that side is charged, that charge is going to transfer into the bolt and have a magnetized end. So you're creating a magnetized end, and what he has is like a carriage bolt where they're round, and he has a spark gap. So I believe he has this wheel cut off in segments. I almost want to say half, but I think it's 4. And the only reason I keep thinking 4 in segments, in quarters, where it's north, south, north, south. And I believe that's the way it's set up, because if you take a compass and go inside Ed's wheel and my wheel, you'll see that north and south flop from bolt to bolt when you move the bolts from bolt to bolt. Now, it's hard to tell with the magnets all being around what is really going on. So I always disregarded the fact that the bolt would change its poles. But the more I keep looking into it, the more I'm realizing, even shield the magnets, that I realize that nothing's changing, that they're staying poles. So these 4 poles on these bolts also representing these bolts that are in the concrete heading towards the magnets. So he's moving, he's moving load, I would call it. He's moving load through the iron to store negative ions. And he's using the iron, because the iron is such a great absorption, as a storage. And then he can pull from the iron. And with the iron, he can also segregate, and it's up to us to separate it. So basically, one ring would be positive, one would be negative. They would be a dipole, swapping right in front of you, right here. As the wheel clicks by, when it's hooked up right, they'll be swapping. With that swapping, that means the top of this handle here and the bottom of this wheel would be another dipole, is a vertical dipole. This is more like a horizontal dipole, because remember I said the bolts inside, I don't know if they flop. And to tell you the truth, the only way to get anything to flop here, nothing flops on its own. Even if you have it all magnetized, it stays permanently pole charged all the time until you wrap the coils, the copper around these magnets. Only then can you reverse the pole in the coil, and it reverses the pole on the magnet, and it doesn't screw the magnets up. They're great being pole transferred. The pole, it doesn't really matter. I mean, I charged them on the same natural pole they are. But what happens is when these get reversed, when the reversal stops, it's going to charge back the opposite way. So they become recharged in a sense on the back, on the front stroke, I would call it. Then the back stroke is like a spring, pretty much. So that's how these magnets act. They're pretty unique, and if anything, I noticed that was strange about them is the fact that they swap poles and they're not affected. Neodymiums, you kill them. Forget about neodymiums. You snap them together, they damn break. But these here. These here have unique attributes about them to where they're swappable. You can recharge them. Right now, they got beautiful charge to them. Here goes one that's not charged. Let's see what you guys can see. Let's put you down a little bit. Here's a charge for you guys earlier didn't see it. Hard to pick up, right? Real hard. It's just beat down. It's from the PMH. If the PMH is hitting these magnets from on the opposite side or pole to pole, then it blows the magnet. It makes the magnet no longer magnetized. That's how you take a magnet out of a magnet. Ed says a stronger magnet can demagnetize a weaker magnet. That's how you do it. You put the opposite pole on it and you overcome it. It's like kryptonite to the magnet. So over here I got 24 volts in this thing, and we're gonna first come over here, check the polarity, and that's south and that's north. So we want north on this side, okay? And what we're going to see watch how this moves. Not so fast, right? Somewhat responsive though. Then come over here, and I'm gonna go ahead and I'll go ahead and charge it. It's 24 volts, brand new marine batteries, 135 amp hours at 1 amp. Okay, so now we'll come back, we'll check poles. You got north, south. Look how snappy it is this time. Not sloppy, it's snappy. In fact, let's check right here. Let's go back. Let's go back down here. Let's check it again, north, south. Let's go over here and I got the big bar, right? Now we knew the other one couldn't even pick this up. Let's give it a test. Oh yeah. Oh yeah. Nothing. Now let's go ahead and grab another dead magnet. There's another dead one. I ain't picking up nothing. So got a little strength to it. Let's see if it picks this up. I doubt it. No, so let's go ahead and check the poles on it. Go ahead and instead of moving you guys, I'm going to charge this one. Come over here, we're going to go after the big one first. Look at that. All of a sudden. Give it another shot. I don't think it likes that. A batch of some weak ones there. Uh-oh. So ones like that must have more iron in them than the mixture when they made these magnets. So I'll put them aside. I'll put them aside. I mean, it's still got good strength, so. But they're not my Superman ones. So guys, so back to this. If you're curious why I got wire coming out in concrete between that and that, the concrete is obviously keeping those separated. But I have 4 strands bell wire just running around in that gap area for down the road experiments. Now, I just wanted to see what happens to a loop of copper wire in motion around a magnetic field. So that'll be some down the road tests we'll figure out. If you guys want to leave your comments of, oh, you guys can't even see it. If you guys want to leave your comments, this wire here. So I got 4 strands runs in between this round ring and this gear ring that's separated through the concrete that's in there. And it makes 1 loop. So when you take copper wire, I heard, and stick it through a magnetic field that's in motion, it's supposed to have some different attributes about itself. And I can't realize what it would really have, because inside the copper wire, when you get current, or to get current, you got to just re-angle. Just say if the positive and negative dipole is facing this way, so it's not moving through the wire, and say you slant it just a little bit, it'll start running. So that's how it runs in a spiral and starts moving. So you just have to slant it. And that's interesting stuff to know, because once you know how to slant your dipole, you'll see you'll see current, and that's what I'm getting at with the 4 wires, because it's in a magnetic field and it's also in motion, and it constantly should have current. And I guess I haven't checked that theory, but these are things I read and what I've seen online in different documents with James Wyatt Prentice. You guys check him out if you haven't ever heard of him. He was an electrical engineer for the railroad, and he worked a lot with what's the guy from Steinmetz, little Steinmetz, and he was the electrical engineer for the railroad, and he done a lot of crazy cool experiments, especially running one I read about, which a couple I read, but in his patents, 4 inches off the ground for I think for half mile long, a quarter mile. He broke it down. Hey, Tommy. He broke it down into harmonics, and he had 2 wires up there. One was longer and one was the other, and one was shorter, but broke it down in harmonics. And they had current coming out of them. Remember, the railroad had, capabilities of running metal, steel railroad down, and he was able to not only use that to check things out, but he was also able to try experiments that are above and beyond the railroad's capabilities. And I think he must have been in the Tesla, James Wyatt Prentice. So look into him. Great reads, great patents with him. He's right down the path with all the greats in some of his experiments. So right here you can see that these magnets here are very strong. I'm gonna hold them down, and they're building up in strength. Shit, they're building up in strength as you put them next to each other. I think some of these magnets just die after a while. I don't know. Some of them I gotta put it aside because they don't hold the charge so long. But it's good to get them all nice and charged together. This way, the wheel's like a permanent dipole, let's just say. All right. So the wheel with the magnets, all right, let's just say that. So the magnets isolated from the frame make the magnets are a dipole. That's what a dipole is what a magnet is. It's 2 separate poles, and it's isolated from the frame. But when you go ahead and you send a charge, a magnetic charge, through induction, so we know that this magnet in the neutral area, not much going on. So that's why this ring and this ring is backed by the neutral. That's one thing I realized with Ed, is that he kept those in towards the back. He could have brought them up further, but I don't think he wanted to influence the ends with anything going on in the center. So he does mention that the ends of the magnets were harder and the magnets dampened. Well, dampened or dammed. They actually dammed up, and the strengths were at the very end there. So yeah, so guys, pretty much got the gist of it. I think this is a long enough video. Another day I'll get in here. I'm gonna wrap all the way around. Then I'll do another live broadcast. Maybe I'll do, once I get it 3/4 around, I'll do another live broadcast. We'll bring it all together, check all the poles all the way around, make sure they're north, south, snappy all the way around. And then we'll proceed to get it all lined up perfectly, crank it down, and then we'll work on our angle bolts coming in from the back. And we'll check the poles on those angle bolts that we spoke about. We'll get the center ring off. We'll concrete this here. And then we'll strip the board off, carry it over to the rotor. And we'll get it mounted on the rotor. Then we'll put the centerpiece together. And then we'll work on the little keeper that'll come off of this for a spark gap. And we'll see what that's all about, because you're going to have 4 different poles. One of these go into one of those magnetic poles that are sticking out of the bolts that'll be inside one of these rings here. It's pretty interesting how that's going to transfer, because I guess if you think about what happens when you turn the wheel, you're creating, it's a flywheel, so you're creating centrifugal force. Now with centrifugal force, you're doing something in a sense that a tornado does, and you're doing something in a sense that a hurricane does. It takes the air and the energy and puts it in motion. So putting the air in motion and then having a controlled, I'm saying, electrostatic field in the middle, you're going to create a lot of, I would say you're going to create a lot of things going on between the keeper bar, this upper ring, this lower ring, with them switching. Keeper bar firing off to every time the pole flips on the bolt, because the bolt will be flipping along with the coils of the magnets. So you're going to have the bolt reacting off the magnets. The bolt is reacting to the chassis, which is grounded in itself. The chassis is going to be its own virtual ground and not grounded to the ground, because we have the pipes. And that's where the pipes are going to be isolated from the wheel, from the magnets, from the magnetic field, from the vortex, and from the whole array. So everything is isolated in individual parts. So I guess we'll get into doing a video with different segments of the parts. I guess I'll have to get the whiteboard out, the chalkboard out. We'll do it in little segments. Everything I just said, I'll go back and figure it out. But there's all different little segments. But it's more about not using the wheel to make electric. Okay, guys? It's more about learning what the energy of what you can do it differently than just use it for slavery, as us humans use electric for now. Is we found a new slave. So this slave is electricity, and we use the dog shit out of it. And I don't really care for what we do with it, but I guess it does help us. And the other parts of the energy is that we're standing on basically one terminal here. is the Earth of this battery, just say. And the other terminal is the outer stratosphere, but also air, which is very chargeable. And once you get it excited and charged, it's moving through the magnetic field. And basically what I'm saying is electricity is everywhere because it's static. In all air on inside the bubble here, it's static because the electromagnetic fields are perpendicular, 90 degrees off or whatever, but there's no 90 degrees off to static because static's everywhere. But to get the 90 degrees to get motion, that's how you get electromagnetic waves traveling horizontally around the planet or even vertically. They get caught up in the magnetic field and some go up, but what you're doing is you're opening up a corridor from me to you horizontally, and you're cutting through space itself, time, space, the fabric. That's what it's all about with the energy, guys. All right, man. Peace out. Leave your comments. Hopefully you guys enjoyed. Thank you very much. Happy holidays. Got my holiday shirt on. Peace out. All right, go already.